Don't panic yet.
Panic later.
There's always time to panic.
Hello and welcome to the Hackaday podcast. I'm Elliot Williams, editor-in-chief of Hackaday.
And I'm Tom Nardi, managing editor.
This is episode 170. This week we'll be talking about poop shooting lasers, the Positron 3D printer on its head, DIY pulsar capture, and GPS's Achilles heel. In the news this week, we've got contests old and new. We have the announcement of the finalists for the first round in the Hackaday prize. So congratulations to the planet-friendly power finalists. We saw a whole range of projects here, ranging from the kind of extremely practical DIY to the out there on the edge of harnessing wind or solar or, the electrical potential of growing moss.
Yeah, awesome mixed bag, right? Like, you don't want the real obvious stuff. That's what we do this for, is to see the path less traveled, maybe.
Exactly.
We had been talking about earlier about the kite propulsion, which is a really unique thing. At first glance, I didn't quite get it, but the more you look into it, and it's a very impressive setup. I'm not sure we'll be using kite-powered cars anytime soon, but I'm intrigued by the possibility of harvesting the wind that way.
Kite-powered robots. So this one's got OpenCV, and it's aiming to steer the kite around from a little robot that can get pulled behind it. The demos look awesome / barely controlled. It's a great, interesting experiment. On the other hand, this is coming from Erin Robot Girl, so she knows what she's doing, and she'll have legit. A good time with it.
It's funny. When I look at it, I almost think it'd be cool for exploring other planets or something. I don't know.
Yeah, right?
I don't know how great it'll work here on Earth. There's too much crap on the ground, but I can see one of these things trundling along on Mars or something.
I mean, I know they had one that we'll put the robots in a big balloon and we'll have them tumbleweed around in the,
right?
Rolling on the ground in a big inflatable bag. And so this isn't that far from that, is it?
Yeah, right.
There's, one that I thought was really interesting and is kind of a long ongoing project is Fab's mostly 3D printed Pelton turbine. He's been working on this for quite a long time, and it shows. There's a lot of refined and repeated print and fix going on here, and that's really interesting. The parts look super industrial. It's actually working pretty well. So a Pelton turbine's a water turbine. He also had one in there that's a wind turbine that ranked super high in the judging, but we thought it would only be fair to give him one prize instead of two.
One turbine per applicant.
And there are just a whole bunch of projects, like I said, ranging from the completely reasonable to the completely wacky. Moss microbial fuel cell is on the edge out there and is using the kind of, again, small bit of potential energy that you can get out of microbes growing on moss roots. And in case you think this is crazy, this is an area of current research in kind of power harvesting to see if we can use plants, because plants move ions around as part of their, what is it called in plants? It's not their circulatory system, but it kind of is. What is it called in plants?
I don't know.
Anyway, that.
Yeah, I too am drawing a blank.
Anyway, that. You can use them to make electricity from that. And the demo here it's quite honestly, it's a few seconds of power out of an LED from a, kind of 10 square centimeter patch of moss and microbes. But heck, that's not bad. I mean, that's a lot more than I would have expected, frankly.
Yeah, I give this one credit too. I mean, it's really cool if you go back to the prototype, which is Tupperware and tinfoil, that just kind of show there's a potential. And I was looking at that oh yeah, okay, sure, I get it. And then it kind of morphed into this circuit sculpture thing,
right?
Which even if it's not particularly practical, I mean, it's a great discussion starter. You see this beautiful handmade flower blinking away with no external power, and at least get you thinking.
I mean, and I think the end goal for this kind of power generation is much more along the lines of let's coat entire roofs in this stuff than let's make a little dish that can sit on your desk as a demo. And that's what's awesome, is to see hackers playing around with this stuff even on the small scale. So love that one got in there too. So that's the end of the first round of the Hackaday prize. The second round, which is all about recycling, is still ongoing. So get your recycling and recycling facilitating projects into that one. But if you're looking for something completely different, we're also running another contest on Hackaday.io, Odd Inputs and Peculiar Peripherals. This is another contest that's sponsored by DigiKey. So there's a few, I think $350 DigiKey shopping sprees on the line for this one. This one's all about showing us your craziest computer peripherals, whether that is a keyboard, a joystick, a mouse, a data glove, I don't know, whatever you want, whatever it is. If it intermediates between people and computers, we are wanting to see it.
I know. We're going to see a lot of cool mechanical keyboards because that's like the thing right now, right?
Oh, yeah.
But I am hoping to see something a little bit more imaginative. We have, there's some virtual reality, like special categories and that kind of thing, wearables and that sort of kind of fringe. So, I mean, feel free to enter your crazy keyboards. We're happy about that too. But we're really looking to kind of think outside the box on this one. I'm looking for some nice Kerbal Space Program controllers. That's always a cool one.
This is like a super favorite topic of mine because, I sit here all day long at this little keyboard
right?
typing into my damn computer.
Surely there must be a better way.
Yeah, right? And I love to play around with alternative input things. God, a million years ago, I probably read about this hack on Hackaday, actually, and then replicated it myself. I took an old 5.25-inch hard drive platter. So it's one of those with the many stacks of rotating rust platters, and turned that into a scroll wheel with a little bit of firmware on the back end. And that thing was awesome because it's on these fantastic bearings and it just spins and spins and it's so buttery smooth. Back when I did this, I was reading a lot of academic papers as PDFs. So I spent God knows how much of my day scrolling, right? Reading 100-page long articles on the computer, right? And so you're just scrolling all day. And it was actually really awesome to have a kind of a big dedicated scroll wheel. And so I think there's probably a lot of room for these kind of, strange and imaginative single purpose devices as well, because that little scroll wheel on your mouse is stupid if you're scrolling that for 3 or 4 hours a day. That's just not, that's an ergonomic nightmare, but it's also just it's lame. There's something that, about actually moving something that's got inertia, spinning something that you really have to spin,
Let's hope you're not alone, right? Let's hope there's more people out there who want to build these kind of one-off things and show them to the world.
So, right, if you've got recycling projects, you have to enter them into the Hackaday prize. If you've got inputs and peripherals, you have to enter them into the Hackaday.io contest. Whew, it's a lot going on.
This is a journey into sound.
What's that sound?
What's that sound?
And that brings us to this week's What's That Sound? This week is a sound week. Tom, do you want to give it a shot?
Absolutely. I made sure to download it ahead of time this week, too.
Hot diggity.
For less fumbling with keyboard.
That is professionalism, ladies and gentlemen.
I am going to say I should know it. But I do not. I am ashamed to say I do not. I think this would be one of those ones where we get a lot of very passionate right answers.
That's correct. I think so too.
And I'll be on the wrong side of history.
I was like, I wonder if I could get the theme song from blank. And I was like, yeah, I could find it on the internet. That's not how I remember it at all. So we'll see if some other people can find this. The theme song from blank.
That should be my guess, because that part's easy, right?
Yeah, exactly.
It's definitely a theme song.
Yep.
Take my partial credit.
You get half a t-shirt for that. You could have one sleeve. Well, if you know what it is, head on over to hackaday.com/podcast. You'll find a form that you can fill out the name that you'd like to be called on the air, an email to contact you if you have the right answer, and of course, your guess. And next week, we'll read a few of them out, select randomly among the correct ones, and somebody will be getting a Hackaday podcast t-shirt. Yeah, so first up in hacks, 3D printing fabrics is easier than you think. This is kind of an overview YouTube video by Sarah Alvarez of different techniques she's been using to play around with 3D printing fabric-like things. And in the video, she demonstrates, among other things, some shoes that she made, but the main topic is just kind of how you can make things that, I don't know if they're technically fabrics, but they definitely have that kind of fabric-y affordances. Like it's foldable and it's, stretchy maybe, et cetera, et cetera. And she goes through kind of 4 different methods to achieve this with 3D printers, because usually, you think of a 3D print, you think of kind of, a lump of plastic, right? And not something hard, with sharp corners or whatever. How do you make something more fabric-like out of this? And her first suggestion is, well, you can kind of do essentially a chainmail. You can have a bunch of links that all go together into a big fabric, and that's awesome. She kind of briefly talks about writing custom G-code, and the example she has there is actually one where it extrudes a thin bit and then a thick bit and then a thin bit and then a thick bit, and it kind of makes blobbies. And the blobbies all link up with each other. So there's kind of flexible parts where the extrusion was thinner and connected parts where the extrusion was thicker. I thought that was a really neat approach, but it's kind of more technical. And she says this in the video, actually. She's like, this is the way you want to go if you want like utmost control, but you also kind of, no slicers are designed to help you with this. So you're kind of on your own with the G-code. If you want to use the slicer, she suggests kind of a modeling approach where you can just do it all in CAD, basically, and let the slicer sort it out. And this is how she suggests you could do some lace. And she actually has a really cool-looking example there. And then the other is you could just trick the slicer into doing only infill. So you don't print the top layer, you don't print the bottom layer, and you tell it not to print the sides. And it just kind of prints for lack of a better word, a foam of the 3D printing inside stuff. And if you do any of these out of more flexible filament, then boom, you get something that's a lot more kind of fabric-like in its behavior.
I desperately want a t-shirt now that says "Do it in CAD and let the slicer sort it out."
Yeah, right?
It's just vaguely threatening enough for it to look cool on a shirt. No, this is a really cool roundup. I'm not, immediately convinced there's a lot of applications for printed textiles like this, but I do really like I said, the infill trick. We've actually seen that used a couple times because, the slicer has several infill patterns already built in, like automatic, that it'll design to fill whatever volume needs to be done. So, if you wanted to make some kind of plate with a bunch of hexagons on it, instead of having to take the time to model that, you can just, give the slicer a big slab and say use, the hexagonal infill and just don't print the top and bottom, and boom, you have like a hex pattern. And I've used that a couple times because it's just faster than modeling it, let the slicer do what it's good at. We covered somebody who was using that to make like air filters too, if you have a real tight hex pattern. So it is a really cool trick, even if you aren't trying to do the fabrics. There's a lot of ways you can bend the slicer to your will and actually save a lot of time.
Like most of the prints I do are of the kind of big clumps of solid plastic type. But I've also played around with a couple of other people's designs where they do like living hinges. So you print a really thin layer and then you can fold the thing there. There have been a couple neat box designs, for instance, that you can print flat and then fold up. And that's something where it kind of crosses this border, like between a fabric thing. Like Sarah here is aiming completely at fashion, whereas I'm thinking about function, right? But I think there's some crossover with things like living hinges and things like, I mean, there's all these problems sometimes when you have a 3D print that you need to print in multiple parts and then you have to align it to put it back together. If you could make like a flexible quasi fabric-y hinge part there and could fold it together, then the alignment issue's sorted for you and you don't have to worry about that. So I think even for the kind of, utilitarian functional printing that I do, there's some tricks here that I should probably be learning and playing around with. And then there's also, so here she's trying to print fabric. There's also this kind of strand where people are trying to incorporate fabric into their 3D prints. And we've seen couple really cool examples of this. Billy Rubin did a Remoticon talk about this, and David Shorey brought some of these to SuperCon, and I got to play around with these in real life, and he actually just kind of let them out on a table, and everybody was walking by, like, playing with these fantastic 3D prints. And again, it was, you'd print a 3D printed layer, you'd put some fabric down, and then you'd print some more 3D print layers on top of this, and then the fabric would kind of get embedded in the 3D print itself, so that you could have things like, scaly armor, or like there were some really crazy looking things, but just because there was a fabric in there, they just felt really cool to play around with, and it was a really neat. It was just a neat experience. Like, living hinges in 3D prints is a really cool trick. I think this is kind of an allied really cool trick that people should be looking at too.
Prusa did a video on like printing a logo on t-shirts too,
Yeah, right?
Instead of embroidering a shirt, you can just kind of stretch the shirt over the thing and print it right on there. I don't know how many times you're going to get through the washing machine with a piece of PLA hanging on the front of your shirt. But I mean, it'll look cool for the first time, right? In either event, whether you're printing, a fabric or you're putting the fabric, in between, they both at least really play to the strengths of the technology, right? They're either way, it's something that would be very difficult to impossible to do with a different machine, So I do really appreciate that it is really kind of grabbing the desktop 3D printer and pushing it to the edge of the envelope. And even if it's, maybe more for cosplay and decorative stuff than practical, I mean, at least it's exploring different manufacturing styles that would be otherwise impractical for like the home, DIYer.
And some of these fabric things that Sarah's doing here don't just use the form of the 3D printing, like the chainmail or the modeling or the infill method to achieve their goals, but they also are made out of stretchy filament. So you can use one of these flexible filaments like TPU. Or have you ever played around with those? I never have.
Yeah, they're cool, but they can be a hassle. As you can imagine, it's like trying to push a wet spaghetti through the extruder, right? Because the filament itself doesn't want to necessarily cooperate. So usually you want a direct drive printer that's got a nice grippy extruder on it. I know if you got something with a Bowden tube, it can be a nightmare, because by the time the flexible filament gets to the hot end, it's like a spring, it's compressed.
It's flexed.
But there's a lot of cool stuff that you could use with these different materials. So I mean, again, that's a nice flexibility, no pun intended, offered by these machines. That it's not just the technique of layer by layer 3D printing, but also the materials themselves that lend themselves to these creative applications. There's actually a trick. This is kind of maybe off topic, but there's a trick if you just want to do something semi-soft, like a gasket or something. If you print it in PLA and then soak it in brake cleaner, it does something. I don't know the science of it, but it breaks something down in the PLA and makes it flexible. So that's kind of like a expedient hack. If you need to print something flexible, but you don't have any flexible filament, but have a bunch of brake cleaner around and plenty of fresh air, you can soak it in there. And I've done that before, and it actually does. It comes out like a hard rubber. You can flex it, and it'll go back to its original shape. That's pretty cool.
Oh, that is cool. I wonder if we've ever written that up on Hackaday.
I don't know. It's possible.
The idea is new to me, so I think we must not have.
Maybe. I don't know where I saw it. I think when I first saw it, I was like, "This must be fake. This doesn't make any sense." And then I did it. I was like, "Oh yeah, wow, it really does. It really does work. It breaks down some binding agent in the filament." From unusual printed objects to unusual printers is the segue for this one.
Right?
Portable 3D printer gets even smaller, faster, and better. Dan Maloney wrote up about the Positron V3 portable printer, which is perhaps the weirdest 3D printer I've ever seen, and I'm willing to bet that you've ever seen. If you haven't checked out this post, you got to look at it because it is. I guess to start with, it's upside down, right? We'll start with the most obvious thing. The bed is on the top and rises vertically, almost like a resin printer, I guess you could say, but it's not. It's a filament printer. The hot end is on the bottom, and to make things extra special, it's a 90-degree hot end. So the filament comes in the side and makes a very tight bend and is extruded vertically, and yet works, even though every fiber of my being tells me that shouldn't work. The motion is Core XY kind of style, but instead of using belts, because that would be too easy, it uses cables. And it might not be immediately obvious, but as is explained in the video, the cables allow the actual pulleys to be in any position you want. You can have the pulleys 90 degrees to each other because there's not a belt that needs to engage with the teeth. The cable can be at any kind of orientation. It uses pancake steppers to get the weight down, and there's a lot of talk about like putting the center of gravity as low as possible, which all kind of works towards being as fast as possible because all of that moving mass is now real low instead of being suspended vertically on a more traditional kind of i3 style printer. It's able to move very quickly, very accurately, as the added bonus, or maybe it was the original bonus. It's kind of this printer hits so many different keys. It's almost hard to say which ones were like the goals, right? It can also fold down into a very small space because all the working mechanics are in the base, so you can just kind of fold it down. The hook here is that the whole thing can actually fit inside of a box that filament came in. That's kind of like in the video he starts up, you got all these little boxes of filament and one has this printer in it. It's a wild piece of engineering. It's gorgeous, honestly. It looks like something that should be in space. it looks like technology beyond our own. Practicality, I'm not 100% sure about. I mean, granted, you have the extra speed, and okay, it's easy to pack away. I am a little skeptical about getting the prints off the thing when they're upside down, but I suppose that's not any worse than a resin printer. But I guess the biggest takeaway is that, we kind of take for granted, I guess, 3D printers now. They went from these exotic things that you had to build to you go on Amazon and you just buy it. It's not a big deal. Projects like this show that there are still stones left unturned, and there are ways to approach the design that we've kind of all just assumed is going to be bed moves back and forth, hot end goes left and right. It's a solved problem, but there's still room for evolution, I guess. And I'm not sure I'll ever have a printer that looks like this personally, but I'm glad that someone does. I'm glad that people are out there experimenting with it and seeing what develops.
Yeah, I love the cognitive dissonance that it creates because it's printing upside down, right? But this was one of the early demos. I remember this must have blown my mind about 3D printers a decade ago now, I think, that, you could just run it on its side. They really don't rely super much on gravity at all. It's not like you're putting layers of sand on top of each other. It's,
right.
It's sticky, mushy plastic. I still need to see how the 90-degree extruder head is machined.
Oh, yeah.
I need to look that one up.
It's one of those things where if it was me, I probably never would have even attempted it because I would have just been like, no. That's not going to work. You have enough trouble with a straight through hot end jamming. That's crazy trying to do it at 90 degrees, but you look at it and it's definitely your traditional kind of E6 looking hot end, but just 90 degrees.
Right.
And and I don't think we mentioned that the heated glass bed, that's pretty awesome too, where it looks like the rear defroster on your car.
Yeah, right. Yeah.
At first I couldn't figure out what that was. I'm those are the heating elements built in, and he's got the thermistor attached to it.
The bill of materials here specs copper heater strips for it. So I think they're hand-applied copper heating strips directly to
wow.
a glass bed. The notes also say this is from the Frostfighter company, and it says "too expensive" in all caps. So
I like that.
maybe, find other strips that are 0.02 ohms per inch, it says in the notes. So
Talk about the key documentation. Too expensive. Too expensive. Do not do.
that is important, right? There's AliExpress links for like 9/10 of the parts, and then this one is not cheap and is labeled as such. So pretty cool. Oh boy, if you are scared of a little bit of scatological humor, you should probably just skip over this hack entirely. Caleb Olson points out Pup's packages with his poop shooting laser. This is a follow-on to a previous video of his, and inspired by comments on that video, actually, where he had used image recognition and pose tracking in particular to detect when his dog is squatting and pooping in the yard. And so he could record a database of where the dog's poo was to ostensibly pick it up at a later date. If you've got the database of where the dog's poo is, the next thing you want to do, of course, is automate the removal situation. And so what he's got here is a cheap robot arm with a laser pointer on the end of it. And the question is, can you then take this data that you have about where the dog has left its little bombs in your yard and then have the laser robot arm point them out to you? And the answer is sure. And if you're into OpenCV and pose estimation and all this, which Caleb obviously is, you can do it in, quote, style, I guess. It's a really great project here. I think the application is, of course, absurd, but the things that he learns along the way are fantastic. The whole thing is kind of automated by video. He starts it off by making a particular gesture. It then points to the different little landmines and then watches him so that when he bends over to pick it up in the right place, it then assumes that he's gotten it and it moves on to the next pile of dog poo in the yard. It's really a great, kind of smooth computer vision facilitated interaction between him. Like, it knows when he's done and he needs to move on to the next one. Very, very cool. There's like a whole bunch of things that needed to go on behind the scenes here. Like, he has pictures of his dog doing the deed in his yard, but he needs to actually kind of map these into a physical space on the yard, and then he needs to map that back into the angles that this robot arm should point at to put the laser in the right spot. And so there's some really cool kind of general purpose computer vision problems that he's solving here with a particularly absurd result. I just loved the point where he was like, and so then I decided to have it show me where the poo was with the laser, quote, leading me on a spectacular robot-guided poop journey. It writes itself, right?
Yeah, really. Wow. Everything here is done so well, and it all makes sense. I guess it's only funny because I'm a child internally, right?
That's right.
All of it is totally legit, and it all makes sense, and it's all expertly accomplished. It's funny, when I first read the headline for this one, though, I did kind of imagine this super powerful laser that was just vaporizing.
Oh, see, now that's the way to go.
And I was a little concerned that there was some laser turret shooting a beam strong enough to just, I don't know, blow it up or return it to its molecular origins or something. So at least it's only pointing them out. I mean, I guess the next step would be a little rover or something, right?
Heck,
take the person out of the equation entirely, and that would actually, I suppose, simplify things because you wouldn't have to do the pose detection on the person. Although, I guess you already have pose detection for the dog. The pose detection for like when the dog is squatting is just
it's horrible.
It's horrible, but it's brilliant too. It is, I mean, and I'm sure there's some legitimate application for this. I'm sure like some zoo would pay him money
Yeah, right.
To license this technology because they need to make sure that their animals are staying regular or whatever. Like there's probably like some scientist out there is very excited is very excited about the release of this technology, and we're just laughing about it. But hey, that's what it's all about, right? Solving problems in unusual ways. That's kind of like the hack in Hackaday. So, he solved this relatively mundane home problem, and that the spin-off technology from this, whether it's a little poop scooping rover or something, I'm excited for it. I can't wait to see the next chapter in this laser guided poop journey that he's on.
And the pedants out there will have taken issue. I know I certainly did. In his video, he says that, the computer plans his route from one pile of poo to the next optimally. And my red lights are flashing, and I'm saying, this is the classic traveling salesman problem. This is known to be unsolvable. I think it's, you can't actually do this, but you can come up with kind of really good computer solutions to it. And so, again, this is a silly application, but it's a silly application of like all the right stuff for doing more serious things. And I think that's part of why I think it's so lovely.
So this next one is something that's always been kind of a project close to my heart. Any kind of radio astronomy has always struck me as the sort of thing that's just on the cusp of like the DIY realm. But now with, software-defined radios coming down in price and a bunch of satellite dishes on the side of the road because people are streaming, it's sort of becoming the kind of thing that you actually can do on your own within reason. This next project shows that within reason part is kind of a blurry line, because the claim here is that with a 2-meter satellite dish and the lowly RTL SDR, the little TV dongle that we all have in the parts bin, this guy was able to pick up a pulsar. Not that I doubt him. I shouldn't say that. This is not being skeptical or anything. But when we were talking about this before, I kind of told a story where at InfoAge, where they have the Vintage Computer Festival, there's an old telemetry dish that they converted into a radio telescope, and it's huge. It's like 18 meters, I think. And when I was there last time, they had slewed it around to a pulsar, and they could just barely like pick it up above the noise floor. And I remember the guy telling me, he's like, this dish, it's kind of too small for pulsars. He's like 18 meters isn't really big enough for pulsars, but we can just barely pull it off. And I was like, oh, okay, wow, that's amazing. To pull the same thing off with a 2-meter dish, is incredible. And we kind of were talking about it, and the assumption was that it wasn't like a live thing, and that you kind of had almost like a long duration. You watch it for a while and kind of stack up your signals. And if you look into the PDF that was put together for this one, which goes into excellent detail, by the way, about the software setup, in the end, that's kind of how it's explained. Like, you can't monitor the pulsar live and actually see it do its thing. You have to point the dish, and you have to stack up all the signals, and eventually you can see this peak coming up off the background noise. It's amazing what you could pull off now as a hobbyist. I mean, there's nothing here that's, not to say it's easy. It's certainly not easy. I mean, and there's a lot of the highlights are an old TV dish and an RTL SDR, but there's obviously more. It's obviously a little bit more going on to it, with the nuts and bolts. But it's really just a very inspiring kind of project for me personally, seeing what you can pull off now, and the kind of citizen science that you can do with, if not a big enough budget, certainly enough patience to put it together.
A 2-meter dish is, for the serious astronomers, is small. For like me, that's a pretty big. That's a pretty decent sized dish, frankly. I will say that this is not just an RTL SDR. He doesn't like plug the RTL SDR into that little cable coming off the back of the dish. He's got a little Pelican box, basically, with all shielded and with a bunch of low noise amplifiers and bandpass filters and stuff like that. And it this is a professional attempt at making this go, right? So it's not all of that. But on the other hand, after this amplifying and filtering stage, it is just an RTL SDR at the end of the day, and some really clever software doing, kind of the time averaging that you alluded to. It's actually really nice, written for him by Michael Klassen, who did the software for him here. He says basically, if you're looking at a constant signal, it's really easy to get the signal out of the noise. You just kind of do a long time average. And of course, the noise isn't correlated with itself and it just falls out. But if you're trying that with a pulsar, which is like flash, off, 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 flash, off, 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 you can't average over time because the flashes are a short duration. So you kind of have to take a whole bunch of snapshots and overlay them over each other, aligning the peaks up to then get the peak signal out of the noise. And, I'm looking at some of these graphs, and if you squint just right, you actually can see this little band with your eyes, and it actually is fairly obviously there. And if that's not an artifact, I think he's seen a pulsar. His write-up is actually also appropriately modest about it. He says, everything indicates that I may have been able to detect the pulsar, blah, 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 with my radio telescope. I think he's a little bit in disbelief that he's pulled it off too, to be quite fair. And I think that's fantastic. But, when I squint and I look at his graphs, I can see it. I think he might have done it.
It's good. It's always good to be humble when science is concerned, right? Like, you never want to come out the gate and say, I've definitely done this, because you might have a bad day.
Yeah, for sure.
But he says in the write-up that, he has, with question mark, he says this is potentially the world's first, being able to pick up a pulsar, which is such a small dish. And I would say certainly must be the cheapest setup ever, too.
Yeah,
if it's
right?
not just the smallest dish, but it has to be the cheapest hardware. He doesn't give a total, but it can't be a whole lot. We always think in like the home gamer DIY sense, but I mean, this could be very interesting for colleges and stuff, that might assume this was outside of their realm and they couldn't possibly have something like this. I mean, if you could actually observe a pulsar with this kind of budget hardware, and again, not to say he's just throwing stuff together. I mean, obviously it was a lot of work put in there, but it kind of opens up a lot of possibilities. Like, what else can you see? If you can see that, maybe we've got the wrong impression of what's possible with such a small dish.
Here's the link I just have to throw in, a write-up by David Prucci of his experience trying to listen into the Deep Space Network. This is NASA's super deep space probe satellites out there. And this is a really great write-up of David's long experience trying to listen to extraterrestrial radio signals. It came from outer space, listening to the Deep Space Network. I'll throw links in the show notes. My next hack is a piece of do-it-yourself cryptography. Turtle Auth DIY security token gets redesigned for durable everyday use. This is a project we've covered before. Samuel made essentially a GPG/U2F, Universal Two-Factor token for himself out of a, at the time, ubiquitous blue pill board and a button. And then he made a second version, on his own PCB that would then become his daily carry. This now is yet another revision of it, and it's much slicker and much nicer. That's what I like about this, is his experience of having made the previous Turtle Auth 2.0, I guess it was, and then discovering what was kind of wrong with his design by putting it on his keychain. And some of the things that were wrong were passive components on the outside of a PCB rub off in your pocket, or a kind of sketchy attachment of a USB plug tends to bend a little bit, and if it bends back and forth over time, the metal fatigues and it flips off. So this is his new redesign, and I really like it because it's a 3-layer design using a kind of very thin middle, gasket of a PCB to sandwich the top and bottom together. The top is a capacitive sense button and 2 holes so that the LEDs underneath can shine out. Then there's that gasket layer, and then on the bottom there's what looks like a normal PCB. And you assemble them all together. I think part of the trick here is that some of the connections that go through this little mini insert gasket board have to be electrically valid, and others of them are just there for physical strength. And doing the soldering is a little bit interesting. How you solder something together when it's this like 3-part sandwich is also worth looking into. But the end result is a really slick looking kind of everyday carry crypto key token that you can build yourself, completely open source software so you can verify it yourself. And if you make a couple of them, then you've got duplicate keys you can stash in your safe deposit box and one for your keychain. It just brings all sorts of extra functionality to the table that you can do this yourself. And by making this design so refined like this, it looks like something you'd want to have in your pocket.
You know, when I saw this one pop up, I was like, wow, it looks so familiar. Why did I remember that? And it turns out I had written it up, the first version, back in 2020. And like you said, like the proof of concept is just a blue pill board with a push button wired to it. Like, talk about the Arduino Blink wiring, you know.
Yeah,
like,
right.
There is no easier way to do it, you know. But that was enough, right? That proved, okay, I can do it on the blue pill, and then it was like, let's make it a little bit cooler. And you really can see, like, side by side, to look at the two pictures. I mean, the evolution of it is so clear, you know, and you can kind of see why each decision was made. Like you said, you have these little exposed surface mount LEDs that worked fine on the workbench, and then when it was in your pocket and they ripped off or they scratched your phone or whatever, you said, well, that isn't going to do. The design is outwardly very similar, but you can see those like nice little progressions, and you know there's no nasty through hole solder, you know, to scratch or anything. Everything has been kind of like made smoother and made cleaner and kept the same outside lines. It's actually really cool to see it go from like literally a proto board and a button to the first version to like this now, which could pass as, you know, getting towards like a commercial product. You know, it looks so much more finished, but at the same time you can still see that design lineage. It's really cool. I always love when we can revisit a project and to see how they continue. So much of the stuff we do or that we write about is kind of like a one-off thing, you know, that, okay, somebody did something for one day and who knows what happened to it. But I always really like when we can revisit one and see like that wasn't the end of the road, you know, that there was still designs in front of it. And there's really cool like tips on here. I like the use of like hot glue, I think, to make like the diffuser for the lights, right? Because you wanted to have like a nice little LED glow. And you know, if it was me, I would be trying to print little inserts or something. But he's like, nah, let me get the hot glue. Let me get the hot glue, and I can imagine you put your thumb over the hole and just squirt it in there, and it's good enough. And it looks great. I can't argue with the end result. It looks phenomenal. So this next project deals with something that we know is near and dear to a lot of Hackaday readers or listeners, as the case may be, and that is the manufacturers building things to fall apart on us, right? Like, we know how long something should last, so when it doesn't last that long, immediately we start asking questions, and that's what happened with Tin Fever with Dyson's new battery packs. Didn't seem to last very long, and he was wondering, well, why is this? Why am I getting this error message? And it says, like, sorry, you can't charge this expensive battery pack, please recycle at your earliest convenience. So he started cracking them open, and he started looking at the battery management board on them, and he found something pretty interesting. The battery management chip that they're using has, as you'd expect, the ability to balance the cells in the pack, so that all of them have the same voltage. Except for whatever reason, Dyson wasn't using this function. The PCB he looked at had all the silkscreen had where the parts should go for it, but they weren't populated. So instead of it managing the cells and making sure they all matched, it would just look at the voltage, and once they got out of sync, and he says out of sync by as much as like 300 millivolts, once the cells became out of balance, they say, oh, sorry, That's the end of that's all she wrote, and that's the end of it. And it would tell you that your pack is destroyed, and I hope at least tell you to recycle it. But anybody who's worked with these, batteries, whether it was like a quadcopter or something like that, the proper way to do it is that each cell has its own connection to the charge controller, so the voltage can be controlled individually, so that they all are the same voltage. And the chip had that ability; it wasn't being used. And then he started opening up newer ones, and the newer boards didn't even have the silkscreen parts anymore. Like it wasn't. You could have said at one point, like, oh, well, maybe they were thinking about using it and they're going to add it in a later edition. No, they actually took it away. So they were going backwards, and now there isn't even the chance to have the necessary hardware installed. They are fully committed to not bouncing the cells. The downside is there's no fixing that without redesigning the board, which isn't really an option for most people. The best thing that Tin Fever could do was come up with a new firmware for the board that will remove that check that basically kills the battery pack once the cells go out of balance. It doesn't prevent the cells from going out of balance, but it will at least let you get a little more use out of it. It's not an ideal solution, but it is the best solution we have at the moment. And, he mentions that he released, I guess, an earlier version on the EV blog forums, and somebody was already able to revive one of their quote-unquote dead Dyson batteries by flashing this firmware to it. It's not really a victory because you still have the problem, and the cells will just become more and more out of balance, and the performance is going to degrade. The physical aspect of it is still bad, So like, unless you're willing to take the whole pack apart and redo it, it's just a Band-Aid. The big question is, and I guess the big debate, there's plenty of comments on this one. Like, is it intentional? Do they design it this way so you'll have to replace the batteries? Is it? Some people theorize that if you have good enough quality cells, you don't need the balance, and maybe their internal testing showed that if you zoomed out and look at a big enough sample size, that you have better results without the cell management. It's one of those things I guess we'll never get the real answer to. But I mean, the fact remains that using this firmware, people have already managed to resuscitate some dead packs. So that in itself is an accomplishment, even if it isn't a fix per se.
One of the problems is that if they're at different charge states and you're running them super hard, the weak battery can get hot before the other ones. And hot lithium-ion batteries is one of those things you kind of want to avoid, right? Like they tend to burst into flames. So that's kind of sketchy. And that 1/3 of a volt of difference between them that's pretty huge. So I don't know if I actually do fault the battery management system for at least shutting down on that condition. That's pretty out of whack. And our parents-in-law have one of these Dyson vacuum cleaners, and they hit the batteries pretty darn hard. So I wouldn't be surprised if they're, discharging at a couple times the battery's capacity at 4C but it sounds like they're pulling a lot of juice out of them.
I'm sure, yeah.
And that makes me a little bit sketchy about replacing the last remaining safety in the battery management system firmware. On the other hand, it's totally frustrating that it isn't balancing the packs. So I hear you, but if you can take the In Flames vacuum cleaner quickly out to your terrace that is made of a non-flammable, stone outside porch, I'm totally good with this.
If you got that earlier version of the PCB that still had the spots, because apparently it all comes down to like a handful of resistors that you need to put into place. Had he installed the resistors, would it have worked? Would it have worked with the balance mode on, and not need this custom firmware that, like, as you pointed out, is really kind of taking out your last line of defense that keeps the thing from turning into a hand grenade. But even if that had worked, it was only for the older PCBs, because he says that as of the newest ones, they took them out anyway. So I mean, I guess it would have made there would have been a market for the older boards, the older battery packs, on the secondhand market. People trying to buy them and installing the resistors to revive them. I did also like the one comment where somebody was like, why are we stopping them? Let them make these packs that get thrown out early so that we can harvest the cells once they end up in the trash. Which, I guess
That's right, yeah.
That's the other angle. Like, hey, let them, Dyson make people throw their batteries away early so we can grab them on the second go around.
Hook these up to a balancing charger and you got something.
Pull all the cells out and balance them. I'm not too proud to admit I've taken some laptop batteries out of the garbage and salvaged the cells from them. So I'll keep my eye out for these Dyson ones too.
My first quick hack this week is Samsonov Dima's. The STM32 makes for a cheap DIY USB sound card. It takes an STM32 to connect to your computer on one side, behave like a USB sound card, and on the other side uses its PWM peripheral and some Delta Sigma software to actually put out the audio sound directly. No sound card involved. It actually sounds really good on this one. Samsonov also did a second version where he uses one of those cheap I2S audio sound card modules that you can get for, a few bucks. And he says that his personal implementation with the PWM and the Delta Sigma actually sounds a little bit better. So really cool project for you to check out if you're into microcontroller audio. Next up, receive virtual postcards on this beautiful e-ink photo frame. This is a project by Cameron. It is an ESP32 and an e-ink photo frame mashed together. The ESP32 is programmed to check a particular link and download and display a picture that you can remotely upload to it. And so it's kind of a really sweet way for people to exchange magically ever-changing photographs with each other. And I just love that kind of human interaction that this opens up. And last, Make Anything's video Bicolor Filament kicks 3D printed optical illusions up a notch. This is actually a long video showing a whole bunch of neat projects that Make Anything has 3D printed. But the star of the show is by far a 2-color filament print of these kind of ambiguous cylinder illusions, which made the rounds a few years back by Kokichi Sugihara. These are fantastic. They use the angle at which you're viewing the shape to make it look like, for instance, a square if you view it from one side and a circle if you view it from another, or a butterfly and a star, or whatever. Actually, Kokichi, in the meantime, has made a fantastic explainer video that Make Anything links to. You should absolutely go check that out if you're interested in the math behind these crazy 3D printable optical illusions.
So my first quick hack is PSP turned robot remote with custom software. I really like this one because we don't see a whole lot of projects for Sony's PlayStation Portable. For those who don't know, it was a handheld that went toe-to-toe with Nintendo's offerings and came up in second place. So it doesn't get quite that nostalgia that we see for Game Boy and DS hacks. But for the time, it's a nice machine. It had Wi-Fi, it's got an analog stick, plenty of buttons. Why not use it for other purposes? And the hook for this one is that there is an open source software SDK where you can write your own programs. And in this case, it's a little drone controller that hooks up to ESP8266 on the other side, sends basic commands. I'd love to see it get expanded to, maybe doing video on the screen and that kind of stuff. But now that people are seeing what's possible, and that there's an SDK out there and that you can use these basically in like an off-the-shelf kind of configuration for other purposes, we're hoping to see some more development, and maybe we can catch up on the PSP hacks versus the Game Boy. Next is using a fusion splicer to repair a Samsung TV's cable. Now, this one's pretty interesting. Apparently, newer Samsung TVs, newer and higher end, I should say, have a feature called One Connect, where you have a box down in the entertainment center where all your stuff hooks up, your devices, your audio gear, and then everything is run up to the TV with one fiber optic cable. making it easier to route the wires, right? You don't have this big maze that goes up to the television on the wall. Well, what happens when that little fiber optic cable breaks? Apparently, you throw a TV away or sell it very cheaply. In this case, it got sold cheaply, and the hack here is figuring out how to repair that fiber optic cable and fuse it back together. So it, part of it is figuring out which pair does what, and then in the end get to use this, cool fusion tool that melts the fiber optics and puts them back together. So it's a, part cool repair hack and diagnostics, and part getting a excuse to use a tool that you don't get to use very often. So perfect Hackaday fodder. The last one, long distance text communication with Laura. This is, something we've seen a few times, a little handheld communicator that uses the BlackBerry keyboard and a 3D printed case. But I don't care. Every time I see them, I want to see more. I love that people are reusing the BlackBerry keyboards. I love the idea of these like off-grid mesh communicators. It's a really cool project. It's not, this one, it does involve, a little more customized than some of the other ones we've seen. There's a custom PCB, there's GPS and stuff. In this write-up, there's links to ones that aren't quite as complex if you want to get started with off-the-shelf parts. And I just think it's an awesome reuse of these old parts with new technology to make something useful.
All right, now it's time for our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writers. And my pick this week, Handling Bulk Material, Why Does My Cat Food Get Stuck? By Anne Ogborn, is all about what? Bulk material handling, which is a problem you may not think you have, but once you know what it is, turns out you probably encountered it at some point in your life. The idea is if you've got a bunch of stuff, whether these are M&Ms or sand or breakfast cereal or coins or random screws or styrofoam beads, and you want to dispense them out of something like what I would think of as a funnel, there's all sorts of technical problems here. And just this article kind of goes through a bunch of the problems and how the small particles, when they go through the funnel, they kind of want to pack together, and whether they stick together or whether they break through and flow out matters. How things flow through the funnel, whether it flows as one big mass or whether it flows just through the center where the little hole in the bottom of the funnel is, also matters. There's problems when that happens one way and you don't want it to happen that way, and there's problems when it happens the other way. It's just a really interesting article, and it's it kind of combines a lot of stuff that I've experienced, on the playground, in the sandbox, or in the kitchen or something, right? Like real kind of hands-on experience with things flowing or not flowing through funnels, with then the kind of hacker side of things where you're trying to make maybe a cat food dispenser and it's sticking, and then this is about kind of how to understand the problem, and she's starting down the road of kind of first steps to address some of these problems, and that's coming up in there's going to be a part 2 and a part 3 of this one. But I just think it's lovely the way, thinking about this or reading about how this sort of problem is handled from an actual materials handling engineer perspective, just kind of opened my eyes up.
I know I've said this before. I'm sure I'll say it again, but it just always amazes me when we bring somebody on, a new writer. They all bring a little corner of the world with them, right? Their own experiences and the things they've seen that are totally unique to them and that nobody else can replicate. It's their life experience. And that's how you get articles like this, because nobody else before Anne came on board, no one else would have thought to write this. And now we have her, and now we have this thing, and it's fascinating. And even in the comments, people are like, "Why is this so? Why am I so fascinated by how sand goes through a funnel?" But it is. It's the kind of thing where you can't solve a problem unless you understand it, right? So this is phase 1. Yeah. This is understanding the problem, and this is learning the terms and the stuff like a rat hole. I I had never heard of a rat hole before. Maybe I live a sheltered life, but that's the term when you make this like this vertical column avoid, and you still have stuff packed onto the sides. Oh, that's a rat hole. We got to avoid a rat hole. So now now that you know the name of the thing, we could work on trying to fix it. And I'm on the edge of my seat for parts 2 and 3 of the funnel saga, because it was really it's really fascinating stuff. Like you said, this is something that it's kind of coming from a perspective, of industry, big, huge stuff that obviously we're not really doing, but it does apply. There are applications like, like the pet feeder and stuff like that. There are hacker DIY projects that will benefit from this, even though it is kind of coming from an industry standpoint. And I think that's awesome.
Yeah, Lego sorter, screw dispenser. Like, there's a million different hacker projects that actually kind of fall into this category once you start thinking about it that way. And I think that's part of what's really cool about this. Like you say, this is definitely an industry thing. And a lot of this is like, think about giant grain silos and how you empty them so that all the material gets out and so that it doesn't go out too quickly, and it makes, grain dust that then is an explosion risk. And, there's all sorts of real hardcore serious problems here that we don't experience when we're just trying to get the Legos to flow down into the box. But it's still really cool to see from this perspective. The thing I liked the most was her example when talking about one of the problems known as segregation, or the Brazil nut effect, which is where if you have two things mixed together that are of different size, they kind of tend to separate out when you pour them out. And in particular, if you imagine having like a mix of salt and peas or something, and you pour these out on the table, you can kind of imagine how the peas roll down the side of this little pile that gets made, and the center of the pile is going to be all the salt, and the peas all roll down to the edge. Well, this is a real problem. And then if you have a second stage coming after this that then pulls from the center, you get only salt. And so you can either use this on one hand, you can use this effect to your advantage if you're trying to separate two things of different size from each other. But on the other hand, if you're trying to get the mix to be consistent throughout, then you've got a problem. And I think that was part of what was interesting to me about this article too, is that, for instance, that problem rat holing that you were talking about happens when the material flows down the center of the funnel, but not, and kind of sticks to the edges. But you want it to stick to the edges a little bit if you're trying to dispense something that's like super abrasive, because maybe you don't want to like wear your funnel out. And so by controlling the kind of degree of funneling, you can reduce wear on the bin at the same time as getting all your stuff out. And so like all of these concerns are totally plausible once you hear about them, and none of them are really necessarily good or bad. This is just stuff you have to know about if you want to design a properly functioning bulk material system.
And I'm glad you brought up the salt thing too, because I think a big part of what makes this article so approachable and so fascinating is that it's kind of peppered with easy to conceptualize examples like that. Even though it's being written, kind of from industry experience, she'll break it down like, all right, well, imagine some nuts in a can, like something that we can actually kind of grasp on our level. So you're not lost in this like, oh, okay, well, a 300-ton bin of stuff. What does that mean to me? There's several times where she's like, okay, think of it this way, and like kind of, does something that like, okay, I get that, and then combined with the like the diagrams and stuff, it is remarkably applicable for something that I, by all rights, should never have even seen. This should have no bearing on my life whatsoever, and yet it does somehow, and I can't wait for more of it. Well, my pick this week is from Maya, Knowing Your Place, The Implications of GPS Spoofing and Jamming. And I'm really kind of glad that she wrote this up, because I think this is something that is a big problem, and I don't think people realize necessarily for something that we rely on so much, GPS is, I guess I'm speaking personally, but like I might use GPS to get to the grocery store, you know, like even though I've been there, like I'm completely helpless. Like I use the GPS all the time, every day, even if I'm going, you know, somewhere that I should know. It's kind of like a security thing, right? I like the little moving map and all that. Our whole livelihood is wrapped up in GPS through, you know, not just maybe on the personal level, like getting to somewhere, but even just like shipping and everything. But it is a very easily compromised system, and you know that's kind of the gist here is, you know, she starts talking about kind of the history of GPS and other, you know, satellite based navigation systems and that sort of thing, and how they work kind of at a high level, and then, you know, talks about the reality of that, and that, you know, you're relying on these very faint signals from impossibly far away that get kind of correlated and run through an algorithm to give you a position. And because the signals are so weak, it's very susceptible to local jamming or spoofing. And this kind of hits close to home because, you know, a year or two back, I did a teardown on this GPS jammer. You know, I kept on seeing them on eBay for like $8. I was like, oh, GPS jammer. And I got it kind of thinking, you know, what's the worst that can happen for $8? And the thing terrified me. I came away like really shocked. Like, you could get this thing and it is ridiculously effective because, you know, the signal it's trying to block is just a whisper. Doesn't take much to overpower that. And I did the thing in that write-up. I'll link it in the show notes where I kind of showed, like, with the RTL SDR, like the GPS signal is almost nothing. You know, it actually it's a lot like trying to see a pulsar with a TV dish, right? Like you have to stack the signals because the GPS signal is so low to the noise floor. So it takes almost nothing to overcome that, you know. So this little dinky piece of crap could easily blow away the actual GPS signal. And then, you know, in the comments of that one, people were saying, well, how come you didn't like test how far it could go? And the reality, I felt bad. As soon as I turned the thing on and I saw how effective it was, I realized, like, this isn't just me, you know, it's everybody around me. And I'm not, you know, I'm a couple miles from like an airport and stuff. I was like, I can't be playing around with this thing. You know, as much as I'd love to, you know, give all the information to the good readers of Hackaday, like I'm not trying to be responsible for a plane on final approach losing its GPS or something.
Run your neighbors into a tree.
Yeah, like it's scary stuff, and you know, not to be overly dramatic, but like after I did the write up, I threw the thing away. Like I didn't want any part of it. Like this is not. I felt like it was something I shouldn't have. Like this is bad. This is bad juju. So I got rid of it. So it's ridiculously easy, and I don't think many people realize how easy it is to jam it entirely, and it's not far removed to then spoof it. It's basically the same hardware. It's just a matter of, you know, whether you're sounding out random noise or the actual, like, the signal it's looking for. That's kind of where things get real scary. It's, you know, one thing to just to block GPS, but then if you can spoof it and you can make things believe they're somewhere else, military applications and all kinds of stuff, and you know, Maya goes into that, where the end game, right, on her thing is there needs to be some way to detect this kind of thing, because you may not be able to circumvent it. You know, it might not be the kind of thing you can actually, once it's happening to you, you might just be stuck, but you can at least detect it and know it's happening. You know, even when I did like my own little experience with the teardown, you know, my first thought was, you know, there's got to be some way for it to detect, like, hey, wait a minute, I'm receiving a signal 100 times stronger than I should be. Maybe something's wrong. Yeah. You know, and I guess that would be the first step. If your signal was, you know, this tiny whisper from space a minute ago, and now it's this loud, overpowering thing. Like, wait a minute, let me alert the user that something weird might be going on. But for whatever reason, it seems like we're not seeing that right now, and you kind of wonder what's going to have to happen before that becomes a common feature, you know?
Yeah, there's actually a really interesting comment by Osmarks where he points to an article about the authentication algorithm used in the Galileo navigation system. This is the European equivalent of GPS, basically. And it's interesting. I mean, the problem is that these satellites just can't send out much data. So there's just not much room for any crypto there. You're lucky that they can put out enough data to tell you where you are. You want to add a different layer over the top. But But I do think the authentication idea is a neat one. Part of what sparked this article was some stuff that we were reading about tankers that were going into port in China coming from Iran, where there's actually kind of an oil embargo against them, and the tanker would come closer and closer to harbor and then would just go somewhere else, according to the GPS logs on the boat, right? Like, it would just disappear for a while, and then a few weeks later, presumably after it had unloaded in harbor, it would then leave. And so somebody is actively spoofing GPS in this harbor to make it look like the boats aren't violating international treaties. Like, there's some really dodgy stuff going on with GPS spoofing out there, and it's kind of a neat, I shouldn't say neat. It's the
I'm not
neat
sure
application
neat is the word.
in the sense that Dr. No's killer sharks are neat, right? Like, it's a horrible, horrible thing. But yeah, so there's a lot at stake here, and it does make you think that authentication is, maybe a feature that you'd like to tack onto this. But I also see how it's a really difficult problem too. So I don't know. But yeah, we rely on GPS so much, and these days especially, it's kind of so spoofable. And your jammer was, like you say, absolutely horrible. But, kind of the lowest possible tech. Whereas the spoofing, part of me, just for curiosity's sake, wants to read up on how to do spoofing. And I'm sure there's like GNU radio plugins you can use,
I'm
right?
sure, yeah.
Like, I mean, it's
sure
CDMA, and it's like, the satellites all send out these orthogonal code sequences, right? So like, they all have these kind of, I think they're shift registers that run along inside them and say when they send their codes. And they're all like, you can, even though all the satellites transmit on the same frequency, you can use their individual shift register string seeds to disentangle them from each other. And that's really cool. But it also means that spoofing them is not quite as easy as just, sending random data to open up somebody's garage door. And especially given that it's like hyper timing critical, because, it's the time of arrival that tells you where you are on the Earth. So I think it's a difficult enough challenge to do it, but I might have to go look into. This is just something I've been curious about for a while. I think transmitting this in any real way would be probably illegal. I'm not encouraging this, but boy, I sure am curious.
Yeah, right. Yeah, I mean, I think it kind of is probably on the same level as like running, your own cell tower. The hardware's out there
exactly
for if you're willing to spend a couple grand, and if you're willing to learn the ins and outs, you could do it, and you could probably put it on a backpack size thing and cause some mischief. But I think it's just hard enough and just expensive enough that outside of security researchers, it's not something that we have to necessarily worry about on a day-to-day basis. But, like Maya says, it's nothing for, a nation to do. If somebody's trying to do it for, militaristic purposes, you look at, what's going on in Ukraine. It's nothing.
Or if you have an oil tanker you want to hide, or
yeah, it's nothing for Russia to say, hey, guess what? All the GPS is scrambled here. It's tricky, and part of it is because probably the GPS is ancient, really. If you think about it, I mean, it was an ancient military tech that only later was like, hey, do you think the peons, the civilian peons would like this stuff? Here, give them the GPS. And then it took over the whole world. Really, it went from a military thing to something we all have in our pockets. So it could just be that GPS itself, like literally the US built GPS network is just it's never going to be the secure thing we need, and that Galileo and newer satellite networks are going to be the answer. Like, it could just be you're trying to beat a dead horse, right? You just move on to the next generation, because you're never going to be able to get the kind of security that we need from such an antiquated system.
That wraps it up for this week's Hackaday podcast. If you'd like to reach out to us, you can write us an email, editor@hackaday.com. If you see anything cool or do anything cool, send us a tip, tips@hackaday.com. And as usual, the show notes with all of the links is available at hackaday.com/podcast. And until next week,
keep on hacking.
Poop shooting laser. all red lights are red. And if that project, and if that, and if the first, what am I gonna say?
Yeah, it's because this silly bastard is mowing the lawn with a string trimmer, and that's why it's taking forever. Get a lawnmower. People are trying to make podcasts.